So let's start the new concept, multi-threading. Multi, okay, multi-threading. Okay. So let's discuss what exactly a thread. So I'll say a flow of control is nothing but thread. A flow of control is nothing but a thread. Or we can give one more definition. What is that? A thread is a thread in Java is a small, lightweight process which will perform multiple tasks at the same time. We have seen an example, the examples are, okay, the examples are um, accessing YouTube videos while um, playing cricket. Okay, so this is one of the example, and talking on phone. This is one more example. Talking on phone while cooking. This is one more example. Okay, and there is one more example. Downloading files, sending email to colleagues is a one more example. Multitask you are doing at the same time. So downloading the files and sending the emails at the same time. So uh, first you will be downloading the files. You'll be keeping a download, and then what you'll be like, in between, what you're doing is you'll be sending emails to the colleagues or your friends as well. Okay, these are the different examples for the multitasking. Okay, so hmm, now what is multi-threaded? Okay, what is multi-threaded? What is multi-threaded? So we have seen we have seen a thread, and we have seen multitasking. So multi-thread, what is multi-threaded? If a program contains, if a program contains multiple flow of control, if a program contains multiple multiple flow of controls for accessing multiple flow of controls for accessing or for achieving concurrent execution, for achieving the concurrent execution for achieving the concurrent execution, then that program is known as called, multi-threaded, multiple flow of controls. Okay, so if a program contains multiple flow of controls, okay, a thread is nothing but a flow of control, I said, right? If you create a if there are multiple threads are created, we will be creating a multiple flow of controls for achieving the concurrent execution. At that same time, we want to execute the thing simultaneously. Okay, so here you are accessing the YouTube videos and while playing the cricket. So at the same time you are performing things, and you are like, talking on the phone while cooking it. At the same time you are performing two tasks at the same time. Okay, concurrently you'll be executing the things and downloading the files and sending the emails to the colleagues. These are the one of the examples of multi-threaded programs or multi-threaded applications, multi-thread programs, you can say that. Okay, what is a program actually? What is a program? What is a program? What is a program? The program is said to be multi-threaded program. So what is a program? A program is said to be multi-threaded if and only if in which there exist a n number of sub-programs. If and only if there exist a n number of sub-programs. So this is called multi-threaded programs. The languages like C, C++ comes under the single thread programming languages. Single thread programming languages. The languages like C and C++ comes under the single programming languages. Since there exists a single flow of control, we can create only one thread. Okay. So when it comes to the Java and .NET, which are the multi-threaded programming languages, multi-threaded programming languages. Java and .NET are multi-threading programming languages because there will be a multiple flow of control. Okay. So when we write any Java program, if you write any Java program, so far we have written lots of Java programs, right? When we write any Java program, there exist two threads. There exist two threads. They are, one is foreground thread and second one is background thread. One is foreground thread and the other one is background thread. Here, foreground thread. Foreground threads are those which are executing user-defined subprograms. User-defined subprograms. Whereas background threads are those which are monitoring the status of foreground thread. Okay. So that is a foreground and background thread. Now, let's understand difference between the process-based applications and thread-based applications. Let's understand the process-based applications versus thread-based applications. Thread-based applications. Okay. So process-based applications. In process-based applications, there exists a single flow of control. Single flow of control. When it comes to the thread-based applications, they contain multiple flow of controls. We can create multiple threads, multiple flow of control. So process-based application, examples of process-based applications, C and C++ are the examples of process-based applications. When it comes to the thread-based applications, Java and .NET are the thread-based applications. Okay. So in process-based applications, context switch is more. What is exactly context switch? Let me write. Context switch is more. Context switch is more. When it comes to the thread-based applications, context switch is less. Context switch is less. What is exactly context switch? Context switch is the concept of, it's an operating system actually, and it will switch the control from one address to the other address. So that is what it will switch from one address to the other address. This is called context switch. Okay. And the last is um, process based applications are like, heavyweight components. So like C and C++ are heavyweight components. These are heavyweight components, and these are lightweight components because these are the threads, right? So threads are lightweight components. Okay, now understood what are the difference between the process-based applications and thread-based applications. Process-based applications are containing single flow of control, whereas thread-based application contains multiple flow of control. We will The examples of cross-based applications are C and C++. The examples of thread-based applications are Java and .NET. And in cross-based applications, context switch is more. So switching the address from one address to other address is more actually. Okay. So when we start the, when we restart the C and C++ editors, so it will not choose the same memory space actually. It will be used to change the address every time. So context switch is less actually. It is in very rares, it will be shifting its references. So heavyweight components. So here the cross-based applications are heavyweight components, and these are lightweight components actually. Okay. So let's see without wasting our time. Let's see the states of a thread. So what is a thread? We have seen it. We have seen different ways of different applications we can create. So they are cross-based applications and thread-based applications we can create. Cross-based applications can be created using C and C++, and thread-based applications can be created using the Java and .NET. So mostly we will be using cross-based applications to create the operating system like Windows, and if you want to create any Windows related applications, you will be using these cross-based applications, and the thread-based applications we will be used to develop the web applications like web applications, and mobile applications also we can develop using the thread-based applications. And let's see, we have seen the thread. Let's see the states of a thread. What is the states? What are the different states of a thread? Okay, from creation to destroy, what are the different states the thread will be going? We will be discussing that. Okay, so what are the different states of a thread? When we write, listen carefully, when we write any multi-threading application, there exist n number of threads. When we write any multi-threading application, there exist n number of threads. All the threads will go under different types of states. All the threads will be going to the different types of states. In Java, for a thread, we have five states. In Java, for a thread, we have five states. They are, first one is new state, new state. Second one is ready state, ready state. And third one is running state. And the fourth one is waiting state, waiting state. And the last is halted state, halted state, halted state. Let's discuss the states of a thread. Okay, so as I said, like we have in Java, we have five types of threads. Okay, five different states of a thread. One is new state, ready state, running state, waiting state, and halted state. Let's learn one by one. New state, new state. A new state is one in which thread about to enter into the main memory. A new state is one when you create a thread class, it is about to enter into the main memory. It is about to enter into the main memory. When you create an object of thread class, it is about to create it is about to enter into the main memory. How you will be creating an object of thread class? So we have a predefined class called thread. So we will be creating an object of thread class using thread one equals to new thread, something like this. THREAD thread. Okay. So now this is the new state. The second one is ready state. Ready state. Second one is ready state. 1 minute, I'll adjust my chair. Second one is running ready state. So ready state, it is one of the uh, thread state where it is when okay, minute, you can say something like this. Mm, okay, it is the state where the thread is entered into the entered into the memory space. Where the thread is entered into the memory space and waiting for the CPU for executing. So when you are saying when the thread is entered into the ready state, it is waiting for the CPU to allocate allocate memory space for it. Allocate memory space. Allocate memory space for executing a thread. For executing a thread. thread. So it is the one in which the thread is entered into the main memory. Ready state, the thread will be entered into the main memory, and memory space is allocated for the thread. Okay, allocated for the thread. The thread will be waiting for the CPU, waiting for the CPU for executing the thread. So CPU will be, sorry, this one, CPU will be executing the thread. So when the thread is in ready state, the CPU is waiting for the thread to execute. The third state we have a sorry, not third, running state, running state. Yes, in this state, in running state, the thread is under the in this state, the thread is under the control. The thread is under the control of CPU, which means that the CPU is here. We are executing, we are waiting for the CPU to execute our thread. Here in running state, the CPU is executing our thread. Okay, in this state, the thread is under the control of CPU, which means that the CPU is executing our thread. And the fourth one is we have waiting state. Waiting state. There are different ways actually we can make the thread to wait. Okay, so let's discuss one by one. Okay, so the first is if we make the thread to sleep for some amount of time by calling thread.sleep, you'll be making the thread to sleep for 1 second. So here if I call thread.sleep method, the thread will be going into the resume state, okay, for 1 second. After 1 second it will start executing it. Okay, and the second one is if I say thread dot wait without any time, we don't know when this is going to awake. Okay, so in this state, these are the different states, these are the different stages when the thread is coming to the waiting state. When you are calling the sleep method on the thread will be coming to the waiting state. Okay, if you are mentioning 1000 means 1 second. If you are mentioning 5000, which is nothing but 5 seconds. Okay, so if I am saying thread dot wait, so the thread will be waiting until here we haven't mentioned anything, so the thread will be in the waiting state itself. So if you mention any timing, something like this wait method will also having a overloaded version which will be taking the time as a parameter. If you even mention time, so it will be waiting that time, and after that the thread will be coming to the again running state. It will be coming to the running state, which will be running state in the sense the thread will be under the control of CPU. And the fifth one is halted state. Halted state. Halted state. And even here, if we suspend the thread from the execution also, we the thread will be coming to the waiting state. We have a suspend method. If you want to, we have a method to suspend a thread from its execution. So if you want to, for example, if a thread is executing and you want to suspend the thread, you'll be calling the thread dot suspend method. So the thread will be coming out of the thread will be released by the CPU, and it will be coming to the waiting state until you are like, deleting this suspend statement. So the thread will be under the suspend state or waiting state itself. So when you are calling suspend method, the thread may come to the waiting state. Okay. And the last one is that halted state. The last one is halted state. Halted state. So in this state, the thread will be completing all its execution. So once the thread is completed its execution, it will be thread will be stopping all. The thread will be coming to the halted state. Okay, the thread will be coming to the halted state. Let's see an example on this one. Let's see an example on this one. Okay, so before discussing an example, first let's discuss how to create a thread. Okay. So, okay, as of now, it's fine for this one. So we have, as of now, we have seen what is a thread, what are the different types of threads we have when we write any Java program, what are the different types of thread involved. So they are foreground, background thread. Okay, what are the different states of thread? There are five types. We have one new state, ready state, running state, waiting state, halted state. So we have seen new state, ready state, running state and waiting state. When the thread will be coming to the new state, when we create an object of thread class, at that time the thread will be coming to the new state. Ready state, when we are calling the run method on that method, when we are calling t1 dot run method, the thread will be coming to the ready state. And so not t1 dot run method. So when we are like, after creating the thread, when we are calling the run method, yeah, when we are calling the run method, the thread will be uh, the memory space is allocated for the thread, and it is first time the thread is waiting for the CPU to execute the thread. So what is running state? If the thread is under the control of CPU, if the thread is started executing, who is executing the thread? The CPU is going to executing the thread. So then the thread will be under the running state. And the waiting state, when the thread is coming to the waiting state, when we are making the thread to sleep for some amount of time. Okay, so at that time also the thread will be coming to the waiting state. When we are calling the wait method with some time limit, that then also the thread will be coming to the waiting state. When we are making a thread to, when we are suspending the thread from the execution, at that time also the thread will be coming to the waiting state. Halted state, in the sense, like after completing all the thread execution, the thread will be coming to the halted state. Okay, so this is all about the thread. And in the next video we will be learning about the creation of thread, and different ways to create a thread and all. We will be seeing a thread class, and we will be discussing more on the thread.